Okay, here's what we're gonna do. Okay. It says we're gonna do number 4. It says a ladder that is 12 feet long is sliding down the side of a building. The base of the ladder is moving at a rate of 1 foot per second away from the wall. How fast is the top of the ladder falling when the base of the ladder is 10 feet from the wall? From the base of the wall. So, very good. Taylor is exactly correct. We would probably not have time to calculate this to keep the ladder from falling. But it is situations like this where we can try to then calculate the force at which it impacts the ground and understand would it or would it not break. So again, we're applying calculus almost like a physics situation. So we have a ladder, and I have the ground, and then I have a wall. The wall's painted blue. Um, and I'm going to call this dimension y. I'm going to call this dimension x. What is the dimension of the ladder? 12. Does the length of the ladder change? No, it does not. It is very okay. Yes, x is 10. The distance away right now is 10. Okay, but does x change? Yes, it's sliding away. Does y change? Yes, it's dropping. Okay, what's happening is the ladder is moving away, and as you slide it away, the top is dropping. Okay. So, but the length of the ladder does not change. So what I need here are a couple things. Number one, I need a good formula. Bo is correct. The Pythagorean theorem is an excellent choice in this scenario. So give me the Pythagorean theorem in this scenario. X squared plus y squared is 144. Now, when you take the derivative x squared plus y squared is 144, you're going to come up with an x prime, correct? Do you know x prime? Yes, we do. What is x prime? What's the rate at which the ladder is moving away from the base of the wall? 1. Do you know x? 10. Do you know y prime? What is that what we're trying to find? Yeah, we're trying to find y prime. Do you know why? We can find it. We know we're going to need to because when you take the derivative, we come up with the 2y prime. So, quick figure out what y is. So 6.6 or 2 roots of 11. Thank you. We can now take the derivative with respect to time. The derivative with respect to time of x squared plus y squared is equal to 144. What is the derivative of x squared? 2x x prime plus 2y prime is equal to, what's the derivative of 144? 0. Right? Because the length of the ladder does not change. Therefore, its constant derivative should be 0. So that's correct. So I have 2 times 10 times 1 plus 2 times 6.6 times y prime is equal to 0. Or 13.2 y prime is equal to negative 20. Divide by 13.2. What is negative 20 divided by 13.2? Negative 1.52. What is my label? Feet per second. Why is it negative? Because it's falling down. Okay? Not too bad of a problem, huh? So that's like number 18 in your assignment. You're going to want to try that. Go fill your bellies with food, and we'll see in a little bit. No, this isn't your notes. Corn is being emptied. at a rate of 35 cubic feet per minute. The pile makes a cone and we're gonna change this, you guys, okay? When the height is 6 feet, the diameter is 8 feet. At what rate? Yep. Basically, the problem that I give you is too easy, and so we need to do a harder problem in order that you can have success on your homework as well as your test. So it says in your it says that the diameter is always twice the height. We're going to change that. We're going to say that when the height is 6 feet, the diameter is 8 feet. Okay, and then at what rate is the height increasing when the height is actually 3 feet? Okay. Bo, what were you thinking? Oh, okay. All right. So this is a challenging problem for a lot of students to get through. And my goal is to be able to teach you it today that you would be able to do it tonight on your homework. And tomorrow we can finish up our related rates. And you guys can have some time to work. And starting Monday, you know, we'll either test or we'll do new stuff. But we're going to test here, you know, pretty soon on this material. For sure by Tuesday next week. So, okay. So let's start this problem. Okay. So you have, do you guys know what an auger is? Okay. So this is a farming auger that is used to basically draw corn um, from a lower space. Like, for example, you can dump the corn from the combine or a truck or whatever you might be carrying in. And then what will happen is it will draw up the auger and either put it in a pile, or it could, say, put it in a silo, could put it in a truck, could do whatever. So it's a way to move it to really one space. No, you're not going to put it in your house. Okay, good. This is different than a fishing auger. Okay, this is, it doesn't have like a track, but it turns and it draws stuff through it. So anyway, so it says that when the height is 6 feet, okay, then the diameter is 8. All right, and we know that its current height is 3. It's not really that big, is it? It's not that height. It's more like that height, okay? It's a height of 3. Well, I'm just saying that we're looking for when it's 3, all right? So it starts small and it's growing, okay? So what are the things that are changing? What are the parts of the cone that are changing here? The height, the diameter, the radius, the volume, those are all changing. They're all changing with respect to time. So what I first want is I want a formula for volume. What is the volume of a cone? Volume is equal to 1/3 pi r squared h. Yes, there's a sheet at the back of your notes that tells you some of those formulas. I will keep that in mind. Okay, so knowns and unknowns. Okay, what do we currently know with this problem? Okay, we know the height is 3. We don't know h prime, do we? That's what we're trying to find. It says, what rate is the height increasing? So we know that's what we're looking for. What else do we know? V prime is 3.5. What else? That's really all we know. Sure, you could say that the diameter is 4 in this situation, or say the radius is then 2. But this doesn't really help us. Now let me show you why. This is so important. 6 to 8 is going to be the same as 3 to 4, so it's proportional. Keen that you see that it's proportional. This is the most important part. This is what you have to see, so focus in on this. When you take the derivative right now, how many variables do you have on your right-hand side? I'm sorry, on your left-hand side. Sorry, I wrote it differently. You have 2 variables on your left-hand side, and they're being multiplied, so therefore I have to use the. So I'm going to come up with an r and an r prime. I'm going to come up with an h and. Do you know h? You're trying to find h prime. So the h's look okay. But you're going to come up with an r. Do you currently know r? Do you know r prime? We don't have any way of finding out r prime. We would come up with 2 unknowns. We have no way of getting around that other than try to get rid of the r altogether. So problem 7, 8, and 9 in your homework ask you to get rid of a variable and replace it with something else. They involve substitution. So we're going to use the principle that you guys just talked about. I'm going to say the radius over the height. If the diameter is 8, what's the radius? 4 over 6. Or r over h would be equal to 2 over 3. In other words, r is equal to 2/3 h. You see that? It is always equal to 2/3 h. It's proportional. Therefore, since I've written a relationship for r and h, I can then make this substitution. I can take this and put it in for r. I could have solved for h. H equals. Why did I choose to solve for r so I'd end up with... Because we don't know r prime and we want to find h prime. So that's why I want h's in my equation. Because I'm looking for an h prime. So now my new formula becomes volume is equal to 1 over 3 pi times 2 over 3 h squared times h. I can't leave it like that, folks. That doesn't work. You have to simplify it. I'm going to simplify it down here since I'm running out of room. Volume equals, what is 2/3 squared? 4/9 times 1/3. 4/27 times pi. What is h squared? H squared times h. H to the third. So this is my new formula. Volume is equal to 4/27 pi times h to the third power. Are you clear with what just happened? That is crucial that you can make that step. Now I can take the derivative with respect to time. The derivative of v with respect to time is v prime. 4/27 pi h to the third. I move the 3 in front. So 3 over 27 will reduce to 1 over 9. So I get 4 over 9 pi h squared h prime. You okay with that? So now, what is v prime? Equals 4 over 9 pi times, what's h? 3 squared times h prime. So 35 is equal to 4 pi times h prime. 35 over 4 pi. Whoop. Equal to h prime. So h prime is equal to 35 over 4 pi. What's the label? Feet per minute. Height is going to be a linear measurement, so we just have to the first power, feet to the first power. So this has a decimal. Did anybody figure it out? I don't care. I have on my answer keys, I have both. And on the test, I have both. You should be able to understand how to convert back and forth, and that's the important part. Yes. Then what? Okay. All right. So here we are. Go back to your related rates problems. You should have been able to do 1 through 6. Now, you can also do 7, 8, and 9. And 18. Yes. Technically, you guys, I want to be clear that you have now seen basically all the parts that you would need to see involving related rates. There's a couple different setups. There's a shadow one and there's stuff like that that I'll show you. But you could really try just about any of these that you want. If you're looking for a challenge, go ahead and try some level 4 problems. Give it a shot. Okay. So, you have the rest of the time to do some work, okay? About 5 minutes.